All right, in this video, we are going to look at the length of an arc. And so we have two different ways to look at this. And we are actually, for the first couple of problems, examples, we're going to be able to use both the definition and the proportion. So let's look at this. It tells us that the length is equal to the arc measure, which is what we have been working on finding, divided by 360 times the circumference, and the circumference is over 1. Remember that the circumference can either be 2 times pi times the radius or pi times the diameter. Now, if we were to move this definition into a proportion, what it would look like is the arc measure over 360, that would still be this part here, is equal to the length of the arc divided by their circumference. So basically, from the definition to the proportion, what we have done is divide by the circumference, and so the circumference is underneath the arc length. And we're going to be able to see that each of these, the definition and the proportion, gives us the same answer. So let's look at some examples here. So looking at number 1, we are given that this is 50 degrees right here. And so since that's a central angle, that means that this arc here must be 50. So that's the measure of the arc there. And then the remaining part, they want us to look at the measure of arc HUG, would be 360 minus 50, which is 310. And so now, if this is the measure of the arc, we're going to look just at finding the length of the arc. And you can see that I've taken and divided this into two parts here, one of which is looking at this in the definition. I wrote the definition in blue, and I'm writing this example in blue, and the proportion. And I wrote the proportion up above in red, and I'm writing this example in red. And my goal is to show you that we end up with the exact same answer. So following the definition, the length of the arc is equal to the arc measure, which was, we found, 310 degrees, divided by 360, times the diameter. And here we know that the diameter was given, or the radius was given to us as 9, and so the diameter would be 18, and so our circumference is 18 pi. So once again, the length of the arc is equal to the measure of the arc divided by 360 times the circumference over 1. And so now we're just going to simplify this. I'm going to take the 310 and the 360. I'm going to take and knock the zeros off of there. And then that gives me 31 over 36. I notice that the 18 and the 36, that will cancel and give me 1/2. And so I'll end up with 31 pi divided by 2 units for the length of arc HUG. If I do the proportion is equal to the measure of the arc, which we said was 310, divided by 360, and that's equal to the length, that's what we're looking for, divided by the circumference. And we said the circumference was 18 pi because the radius is 9. Twice that would give us the diameter, which would be 18 pi. Okay, so now I'm just going to simplify this. The 310 over 36, I take those zeros, make that 31 over 36. I then see that I need x by itself, so this is divided by 18 pi. So I multiply both sides by 18 pi, and I have 31 times 18 pi over 36. The 18 and the 36 will cancel to 1/2, and so that'll give me 31 pi divided by 2 units. And we can see that we get exactly the same thing by using the definition or the proportion. All right, if we look at example number 2, I've done the same thing. I want to show you both the definition and the proportion. If we start here, we're given that this measure here is 70, and if we go across there, then that means that this arc is 140 degrees, and so that's what we are told there. And then if we look at, it wanted us to figure out the measure of arc ART. ART would be this. If the whole thing is 360 and this part is 140, then this part here has to be 220. We are also told that the length of arc AT is 42 units, 42 pi. And so when we look at this, for this arc right here, we have the length and the measure, and what they want us to do is to find the diameter. So if I'm plugging in using the definition, the length of the arc is equal to the arc measure, 140, divided by 360, times the circumference. The circumference is pi times the diameter. We don't know the diameter, and so d will stay in there as our variable. As I go to simplify this, I notice that there's a pi on this side and a pi on this side. They'll cancel out. In addition, I can see that I would knock the zeros off of here and get 14 over 36, divide that by 2, and that would give me 7 over 18. If I'm looking for the diameter, then I know that I need to use the reciprocal of 7 over 18 and multiply by 18 over 7. I then see that 42 will divide by 7, leaving me with a 6 times 18, which will give me 108 units for the diameter. Now let's look at looking at the proportion, knowing that we should get the exact same answer. So we look at, this is the arc, the measure of the arc over 360. So we said that already, that was 140 over 360. And that is equal to the length of the arc, which we were given as 42 pi, divided by the circumference. And the circumference we don't know, so we're just saying that that's pi times diameter, and diameter is actually what we've been told that we're looking for. So here I see that I'm going to take 140 over 36, I'm going to knock those zeros off, and I'm going to divide by 2 and get 7 over 18. On this side, I'm going to take the pi over pi and cancel those out, and I'm left with 42 over d. And I'm going to take now, if I am looking for d, I'm going to cross multiply. And so this is going to give me 7d, and this is going to give me 42 times 18. And the last thing that I need to do then is just take and if I have 7 times d, I need to divide both sides by 7. 42 divided by 7 will be 6, and 6 times 18 gives me that 108 units, which we could see is exactly the same as using the definition.